Hello everybody, welcome to the session 2 of the week 1 course on additive technology, landscape and stereolithography. So, in the last session Dr. Alankar would have covered the brief and the history about additive manufacturing, how did it start, and where is it today, what was the journey that it took, but he also covered another very important point, which is value addition of additive manufacturing. So, today I will be taking you through two things. One is the additive technology landscape, and the second thing is one of the additive technologies which is called as stereolithography. So, we will go in detail about the stereolithography technique, but I will also try and introduce you to the entire technology landscape. Before we get into that, I would like to introduce myself. My name is Akshita and I am working in Wipro 3D as the leader for Advice, and we do a lot of knowledge transfer, workshops, funded R&D through this dedicated group called Advice. Wipro 3D is of course into metal additive manufacturing services, polymer printing, but we also have our own products, that is polymer 3D printers that we will be selling. So, I have been in additive manufacturing for about 11 years now. I have worked a lot with metal additive manufacturing, and I do carry the expertise about the polymer printing as well. So, that is my experience. I think you should know who is talking to you today. So, I hope that introduction helps a bit, and let us get started. We should start with the definition of additive manufacturing, and like you can read out on the slides. It is a process wherein we will add material layer by layer to form a completely 3D physical part. So, that is additive manufacturing. We do it layer by layer. So, these are all 2D layers which will in the end add up to make a 3D part. Another important point to qualify as additive manufacturing is that the input for this particular technology or manufacturing process has to be a digital file. So, as soon as a designer finishes making the model in any software that they have, right, like it could be NX, it could be CATIA, it could be SolidWorks. So, it could be any of these softwares. A design engineer will make a part like you see on the screen. Now, once this particular model is created, then it has to be exported into a file format called as STL. So, this is what we call as tessellation. So, the full form of STL, some people call it standard triangulation language, some people call it standard tessellation language. So, there are different names, but everybody agrees that it is .stl. All right, and like you see in the image over here, right, what you see is that the same model is then completely covered with triangles, right. You can see the triangles on the brown part now. So, when we convert a native CAD part into a STL, basically we are converting it into a surface model. So, the entire surface of the part like you see here is covered with triangles, right. And why triangles? That is because you can get the curvatures of a part, you can transition from a large feature to a small feature easily using triangles. So, that is like a really good element to have to cover the surface of the CAD model. One more interesting thing that you should remember is that these triangles do have sides, inside and an outside. So, over here you are seeing that all the colors of the triangle is in brown color, and that is the outside. Now, if I happen to delete any one of these triangles, which is an error that can happen when you convert the CAD data to the tessellation data, you will see that the color of the triangle on the inside will be different. So, you can kind of look into the part, right, and when you do that you will see that the triangles have a different color. It is also possible that these triangles could be flipped. So, let me say that this is the outside color of the triangle and this is the inside color of the triangle. Now, ideally if I am looking at the part from outside, it should all be like this, right next to each other, but it can happen that these triangles can be flipped. So, that is also another kind of error that can happen when you convert data from a native CAD into this kind of an STL file. These are not the only two kinds of error that can happen. There are a lot of other errors that can happen as well, right. So, you convert the native CAD model into a STL file like you see here. Now, another step that has to happen is you have to then decide in which orientation you want to print this particular part. Now, in the first two images you are seeing that the part is kind of inclined in a certain isometric way, let us say, but then in the third image you are seeing that we have made the part lie down flat on the plate that we will be printing on, and that is represented in the red color. But what you must also pay attention to is the green layers that you are seeing. So, additive manufacturing process is a bit like building a room, let us say. So, the room that you are in right now, imagine printing the walls of it. So, that is pretty easy, right. You will put one layer of bricks, on that you will put one more layer of bricks, on that another layer of bricks. So, the wall gets made into a 3D wall. If you consider each brick as a 2D just for the sake of understanding, then from that 2D brick you will eventually land up with a 3D wall, no problem. But there is a problem when you try to put the roof to the room. So, what happens there is that when we are building the room, we will put up scaffoldings and then we will pour concrete over it. Once the concrete solidifies, then we will take off the scaffolding. Exactly the same principles are applicable in additive manufacturing. So, here what happens is that when you have overhangs that you have to print, right. For example, you see on the right hand side of this particular part here, you are seeing that there is a step, right, and that is an overhang. So, then you have to put supports under it, which is this green part exactly. So, in additive manufacturing there is something called as supports, which are required in many cases to print the part, but these support structures are not a part of the actual component. So, after the printing process is over, we need to remove these supports. So, these are sacrificial in a way. So, this digital input that is required for additive manufacturing is a very important part of the definition of additive manufacturing itself. Now, once that is over, then we will do the fabrication or the printing or the additive manufacturing of the part. Now, the picture that I have used here is from a technology called as laser powder bed fusion. You will learn more about it in week 2, but there are different processes that are available that qualify as an additive manufacturing process. So, this is one of them. So, you based on the need of the part, you may choose any one process and you may start to print the part. So, then you do the actual 3D printing, but there is another step which is part finishing. So, the picture that you see there is an actual part, 3D printed part, but remember that this does not have the support structures, right. The green color support structures that you see there, they have all been removed. So, this we call as post processing or part finishing. In case of polymer parts, it is possible in many cases to very easily remove these supports and use them as end parts. So, the extent of post processing after the 3D printing process is very less and very simple, but in case of metal 3D printing, and that is the picture that you see on the screen, it is it does involve a lot of printing, a lot of post processing after the printing process. You can put the parts through, let us say, things like heat treatment, stress relief. You can do CNC machining, you can do polishing, you can do coating, you can do any of these post processing operations. So, just keep in mind that this end part that you have after the printing process is like a cast part. So, you can put it through heat treatment cycles to improve its property, you can put it through machining process to get a more accurate part or a less accurate part, or a smooth finished part. You can also do polishing. If you need some kind of a coating, you can do that also. So, it is a near net shape that you get after 3D printing, and there will be some amount of post processing to get the final component, right. So, this is a brief of the workflow of additive manufacturing, but also I hope that the definition of additive manufacturing is clear as well. But you will understand the additive process more in detail when we go into each process. This is a bit of a small variation between each and every process, but starting from a digital file and some raw material, which could be polymer, metal or ceramic or whatever, we will end up with a physical 3D part, right. So, let us get into the different technologies that are available as of today. So, there are many different ways in which the 3D printing processes can be classified. For example, one of the ways is according to the raw material. So, which are the processes that are available to 3D print polymer, which are the processes that are available to 3D print metal, which are the processes available to 3D print ceramic. So, this way you can do one kind of classification, but there is another way of classification also, let us say something like form of raw material. Now, in polymer itself, are you using the polymer in a liquid form, or are you using the polymer in a solid filament form or in form of powder. So, it based on the type of raw material or the form of raw material, there also you can do a certain kind of classification, but we will stick to the classification that ASTM has given us. Now, ASTM has categorized the different 3D printing technologies into these 7 categories. And what is the basis of their classification? The basis of their classification is the working principle, right. What is the working principle of a certain technology, and then you can very easily map it to any one of these technologies. So, according to ASTM, these are the 7 technologies that we will go through. We will start with vat photopolymerization, then we will go on to material extrusion, material jetting and binder jetting. these 4 things will be covered by me in week 1, and then starting from powder bed fusion, direct energy deposition and sheet lamination will be covered by Dr. Alankar in week 2. So, the way that this particular thing is arranged is intentional, and maybe 1 or 2 things that I want to tell you about this is VAT photopolymerization. Another name for this is stereolithography. We have put it in the beginning because this was the first technology that got patented or came to be known as basically 3D printing. Now, that was the name that was used for a very long time. Another alternate name that used to be used for this 3D printing is also rapid prototyping, RP. Now, we do not call it RP anymore, but the names 3D printing and additive manufacturing are more common, and I think additive manufacturing is the best suitable nomenclature for any of these technologies, because as of today we do not use additive manufacturing only for prototyping. That was the intention with which it was you can say invented or made, but it is no longer restricted to just make prototypes, but you can make end use parts with this particular technology. Hence, I think a more suitable name would either be 3D printing or additive manufacturing. So, VAT photopolymerization, like I was saying, was one of the first technologies that was put under this category, and then we have other technologies like material extrusion, material jetting, binder jetting, and a lot other things that came up. So, usually with VAT photopolymerization, we see that a lot of polymers can be printed, as is the case with material extrusion or material jetting. But as we move from left to right, what you will come to know as the weeks progress is that powder bed fusion or DED or sheet lamination is more so used for printing metal. So, there is a transition from polymer to metal, but in every technology we will tell you what are the different materials that are processed. It is not that VAT photopolymerization is used only for polymers, but I am just saying that that is probably the most processed material on that particular technology, right. So, another important thing is that there are always a lot of variations which are possible in these technologies. It is also possible that 2 or 3 technologies are combined in a hybrid way also. So, if you look at VAT photopolymerization, for example, you have SLA, DLP, CDLP. Now, what are these? I will tell you in the coming slides. If you look at material extrusion, another name for it is FFF technology, that is fused filament fabrication. If you look at powder bed fusion, there you have LPBF, that is laser beam powder bed fusion, MJF. So, I know, I mean right now it may look like a lot of acronyms and short forms and variations and all that, and hence these sessions are very important, the first few, because you will understand the 7 technologies, but you will also understand what are the variations, what are these acronyms, do they mean the same, do they mean something different. So, all of these things you will be able to understand once this landscape portion of the course is done with. So, that is the hope, right. Let us get started with the first technology, that is VAT photopolymerization, and I told you why we are taking this up first as well, right. There are 3 variations which we will also take up.